Hi, Leo students, Mr. Kaczynski with you. Maybe our last lesson of the year. Here we go. Quadratic formula, yet another way to solve a quadratic equation. All right, let's break some things down here first. Let's go over here and let's define what standard form is. Okay, well, we've seen standard form, but I think we need to talk about it just a little bit more. It is ax squared plus bx plus c equals 0, or y, whichever one. But all right, so rewrite these equations and identify what a, b, and c are. Kind of already done this, but so we'll go fast. Well, x squared plus 8x, and then when I add 6 to both sides, it's going to give me plus 6 equals 0. Okay, so that's important because now we can identify what a, b, and c are. That's standard form right there. So let's identify the values of a, b, and c. A is this 1 right here. B is that positive 8 right there. And C is this positive 6 right there. It's not the negative 6 on the right side of the equation. It's the positive 6 on the left side of the equation after we wrote it in standard form. Let's do this a couple more times, see what differences I notice. Well, I'm going to leave that x squared right there. I'm going to subtract 4x from both sides. I'm going to add 4 to both sides. And when I do that, that'll leave me with nothing on the right side. So there it is in standard form. Let's identify the values of a, b, and c. A is, again, 1. B is negative 4. And C is positive 4. Okay, so we got this 1 right here. We got a negative 4 and a positive 4. Those are the values of a, b, and c. Once we start using the quadratic formula, we're going to need to know all of those. Okay. Ooh, all right. Well, we got to square this binomial over here first. So let's make that x squared minus 8x plus 16 equals negative 3. Remember, it's a squared plus 2ab plus b squared. So x squared is x squared, 4 squared is 16, negative 4 times x doubled is negative 8x. Then I'm going to add 3 to both sides. X squared minus 8x plus 19 equals 0. Now we've got it in standard form. And I can identify that my a value is 1, my b value is negative 8, and the c value is negative, oh, sorry, no, it's positive 19, definitely. There we go. We got a, b, and c. One more of these, right? Ooh. All right, how about we do distributive property here? Let's go 2x times 2x is 4x squared. And then we'll do 2x times negative 3 is negative 6. Oops, that's squared. Negative 6x. And then we'll do 1 times 2 is 2x. And then we'll do 1 times negative 3 is negative 3. That all equals 10. Then we'll combine some like terms. On the left, we've got the negative 6x squared, or the negative 6x and the positive 2x that add up to negative 4x. That all equals 10. And then lastly, we have to subtract 10 from both sides. So we get 4x squared minus 4x minus 13 equals 0. Now that it's written in standard form, I can identify what a, b, and c are. A is this positive 4 right here. B is the negative 4. And C is negative 13. All right. What's the point? Okay, what's the point? Here we go. So I'll show you later, but if you rewrite standard form and you solve this equation for x, it ends up being this equation right here. Color do I want to use? Let's use green. So we're going to go x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That is where this equation equals 0. Okay, so we just have to put b in there, a in there, c in there, a in there. Okay, so now we're just going to start substituting. Here we go. So it equals negative, what's our b value? It's this 1 right here, right? So negative 1 plus or minus the square root of b squared, so 1 squared, minus 4 times a times c. Okay, a is this 1 right here. And c is this negative 6 right here. All over 2 times a. And we know that a is 1. There we go. That's it. Now, if I just start simplifying this equation, I'm about to find the roots of this equation, and I'll prove it with a graph here in a second. But, all right, here we go. Let's go. X is the opposite of 1, which is negative 1, plus or minus the square root of 1 squared, which is 1. I got a negative 4 times 1 times negative 6. That's going to be a positive. 4 times 1 is 4, times 6 is 24. All over 2. Keep going. This is plus or minus the square root of 25 all over 2. And this is negative 1 plus or minus 5 over 2, because the square root of 25 is 2. Okay, so let's just simplify this. Negative 1 minus 5 is negative 6. Negative 6 divided by 2 is negative 3. And negative 1 plus 5 is positive 4. 4 divided by 2 is 2. That should be the roots of this equation. Let's go find out. X squared plus x minus 6. Graph it. Where does this equation equal 0? At negative 3. Yep, that equals 0. And positive 2. That also equals 0. Now, granted, for this equation, not sure I would have even, bothered doing it that way, because I can graph it and clearly see the roots. Or I could have factored it and used the zero product property, because there are factors of negative 6 that add up to 1. Those are 3 and negative 2. Okay, but you'll see that it can be a very useful way, maybe even easier than completing the square, especially when the lead coefficient isn't 1, like this. Okay, I don't want to factor this. And I'm going to try to avoid the graph for right now, but we'll use the graph to check in a second. All right, so let's do this again. So we're going to do x is equal to negative b. B is negative 5, so negative 5 plus or minus the square root of b squared, negative 5 squared. I guess this squared should have been in green. Minus 4 times a times c. All right, a is 2, and c is negative 3, all over 2 times a. A is 2. So if we simplify that, we're going to find out where this equation is equal to 0. All right, so negative 5, that's 5. Plus or minus the square root. Negative 5 squared is 25. You got a negative 4 times 2 times a negative 3. I know that's going to be positive. 4 times 2 is 8. 8 times 3 is 24. All over 2 times a. Oh, wait, sorry. I already did that part. This is 24. All over 2 times 2, which is 4. All right, we can simplify a little bit more. 5 plus or minus the square root of 49. Okay, 20 all over 4. We know that the square root of 49 is 7. So 5 plus or minus the square root of 7 is 4. 5 minus 7 is negative 2. Negative 2 divided by 4 is negative 1/2. 5 plus 7 is 12. 12 divided by 4 is 3. So the solutions to this equation should be -1/2 and 3. Again, I probably could have graphed this and figured out those answers pretty quickly, but we'll see where it's got its uses here in a second. 2x squared minus 5x minus 3. Graph it. Looks good. Trace it. -1/2. That's 0. And 3. That's 0. So this quadratic formula works. It'll find us the roots of these equations. All right, I don't want to factor this. Its lead coefficient isn't 1. I don't want to complete the square. Its lead coefficient isn't 1. It just makes it tougher. So what we can do instead is use the quadratic formula. Okay, so it's -b plus or minus the square root of b squared minus 4ac over 2a. All right, let's try it. -b, it's 2, plus or minus the square root of b squared, which is 2 squared, minus 4 times a, which is 3, times c, which is 1, all over 2 times a, which is 3. So I just plug those things in. X, oops. X equals. So as you get better at this, you can start kind of just doing this stuff on the fly. I mean, -b, -2, that's -2. Plus or minus the square root. 2 squared is 4. -4 times 3 times 1 is -12. Ooh, interesting. Sure I did this right? Yeah, I did. All over 6. So if we keep simplifying there, you'll see why I said interesting, because I get -8 right here. Okay, well, I mean, is this my answer? Well, let's see. Let's graph this thing. 3x, because there is no square root of -8, right? This, I mean, let's just type this in right here. Let's go no real solution because of that -8. All right, so let's graph it and see what happens. 3x squared. Hopefully you're making a prediction on what this is going to look like when I graph it. Plus 2x plus 1. Graph it. It doesn't cross the x-axis. So if it never crosses the x-axis, it will never equal 0. All right, and the quadratic formula kind of told us that. So we get this negative number inside this b squared minus 4ac part, and that tells us that there's no real solution. Let's do another. Ooh, I got to write this bad boy into standard form first. So let's go 4x squared plus 12x plus 9 equals 0. Then we'll use the quadratic formula. So let's go black, purple. So x is -b. Let's just do it on the fly here. -12 plus or minus the square root of b squared. 12 squared is 144. Minus 4 times a times c. So maybe I go over here and I go -4 times a, which is 4, times c, which is 9. And that's -144. Oh, that's interesting as well. All over 2 times a, 2 times 4 right there is 8. So this is x equals -12 plus or minus the square root of 0 over 8. We all know that the square root of 0 is 0. So this is really just -12 over 8. Or negative, they're both divisible by 4, so how about -3/2? Let's graph this one. What do you think this is going to look like when we graph it? 4x squared plus 12x plus the 9. We're trying to find out where this equals 0. See it? Hey, did I type that in wrong? What did I just do? I'm sorry. I typed it in the wrong place. Got it. Graph. Okay, so let's try again. 4x squared plus 12x plus 9. Graph it. Looks like it only hits the x-axis once. That's why there's only one solution. And where does it hit the x-axis? At -3/2. There it is. All right. Good. How else can we use this? Okay, well, we can use it to find x-intercepts. So what are the x-intercepts of this thing? Let's try to do it the old-fashioned way here. Let's just graph it. -3x² plus 6x plus 8. Graph it. Let's go second calc. Option number 2. Left bound. Enter. Right bound. Enter. Take a guess at it. Uh-oh. That's not a pretty number like -3/2 or 1/2 or 3 or -2. So I think we're going to have to use the quadratic formula to pull this one off. Let's go for it. Let's go x equals -b, so the opposite of that 6, plus or minus the square root of b squared. 6 squared is 36, minus 4ac. So let's go -4 times the a value, which is -3, times the c value, which is 8. Oh, man. -4 times the -4 AC. -4 times the A, which is -3, times the C, which is 8. That gives us 96. So this is really plus 96. All over 2 times A. 2 times -3 is -6. I got a negative over a negative. How about we just get rid of those negatives? Make that a 6 there. Make that a 6 there. 36 plus 96. 132. And the square root of 132 is not a perfect square. All right, let's go back here. Graph. And type this in. Let's go parentheses. 6 minus the square root of 132. I have to put parentheses to end my square root, and then I have to put parentheses to end my numerator, divided by 6. That is one of the solutions. That's one of its roots. And let's do this again. Let's go parentheses 6 plus the square root of 132. You got to do parentheses to end your square root, parentheses to end your numerator, divided by 6. I don't think you can use the fraction function of your calculator here. Let's hit enter. Hey, that's the other root. That's practically 0. Remember that. Calculator messes up sometimes. But those are the roots right there. Those are the roots. Find the equation of the axis of symmetry. Well, the axis of symmetry is when you add the two roots together and then divide by 2 or take half of it, right? So let's just get a little secret out of here. The axis of symmetry is like x equals 1/2 times like the two roots added together. And if you think about the quadratic formula, that's -b plus the square root of, plus the square root of -b plus the square root of b squared minus 4ac all over 2a. And then you have to add the other root, which is -b minus the square root of b squared minus 4ac all over 2a. And if you look at these, they have the same numerator, so it's, or denominator. So we can simplify this a little bit. Let's go, we got it's going to be over 2a. The -b and the -b makes -2b. And this positive square root of b squared minus 4ac and this negative b squared minus 4ac, they like cancel each other out. They add up to nothing. So it's just half of that. So it ends up being x equals half of this. Well, how about like these 2's cancel out? And then we just end up with -b over 2a. So the easiest way to do this, to find the the axis of symmetry is to just go x equals the opposite of the b value, -6, over 2 times a. 2 times -3 is -6. And -6 divided by -6 is 1. So that is the axis of symmetry. Now that I've shown you this, you can just use this every time. So if I go trace 1, enter, that's right there, halfway between the two roots. I really have to take my window up a little bit. Shoot. Let's take my Y max to like 15. Graph it. Trace it. 1, enter. 111. That looks like my vertex. Oh, which happens to be the next question. Find the coordinates of the vertex. 111. You can see it right there. That was easy. Find x if y equals 5. Okay, well, this is a different story now because we got to take the equation. Instead of y, we're going to do 5 equals -3x squared plus 6x plus 8. Let's put this in standard form by subtracting 5 from both sides. -3x squared plus 6x plus 3. Let's plug everything into the quadratic formula here. Let's go x equals -b. Oops, that's an x right there. Sorry. So -6 plus or minus the square root. 6 squared is 36. -4 times a, which is -3, times c, which is +3. That's 36. Did I do that right? Yeah, I did. Plus 36 all over 2 times a. 2 times, that's -6. Again, those -6's the negatives cancel each other out. You can't cancel out the -6's because that's addition right there. So let's go 6 plus or minus the square root of 72 over 6. That's the answer. I'll go back to my graph and I'll prove it to you. Let's go trace. You got to do parentheses. 6 minus the square root of 72, parentheses to end the square root, parentheses to end the numerator, divided by 6. That's 5. Let's do it again. Parentheses, 6 plus the square root of 72, end your square root, and your numerator, divide by 6. That's also 5. Okay, so this quadratic formula can be a super fast way to solve equations, especially when the lead coefficient isn't 1. This would probably be my go-to way of solving an equation when the lead coefficient isn't 1. If the lead coefficient is 1, I might try to factor. I might try to use the completing the square method, or I might use quadratic formula. -b plus or minus the square root of b squared minus 4ac over 2a, hey, over 2a, hey, over 2a, hey, over 2a.